Today we're going to talk about types of feedback devices. We've got the resolver, an incremental encoder, absolute encoder, serial encoder, Hall sensors, and Tach generators. Now, Tach generators aren't used very often in servos because of the fact is the speed that we're going to be using the feedback device. We've got the Hall sensor. The Hall sensors are located on, this would be similar to a nut runner. What we've got here on this is a servo. These are the Hall sensors. The Hall sensors are basically a magnetic switch. As the magnet, we've got a magnetic field that's located here. That's going to open and close the actual Hall sensors. Then we've got the resolver. The resolver is basically a rotating transformer. They're very, very rugged. A lot of the resolvers are physically located on the motor shaft, so they don't have they don't have bearings. They're using the motor shaft bearings. They're very rugged. They're used very well into an oily, dirty situation. And we also have the resolver. It's individual, where it does have its own bearings, so that type is available, but on a servo application most of the time it's mounted to the motor shaft. Then we've got an incremental encoder, and an incremental encoder is a glass lens. Your incremental, your serial, and your absolute encoders have a glass lens inside, so they have to be you have to take very, very good care to the incremental encoder. So as it's coming in from shipping and receiving, going across the floor with the fork truck on the back of a cart or a fork truck, if this thing's jarred around, this is just a glass lens, we can easily break the lens. But on an incremental encoder, all we've got is multiple lines around the outside. We've got a light source that comes through, and when it hits the line, it doesn't go through. When it passes the line and it's clear, the light goes through, which sends a signal, and it counts these signals. Then there's one that's called home, that's our Z pulse, and what that'll do is as it's rotating around, the drive will count all the lines when the light goes through and when it doesn't, and then it hits the Z pulse, and then it'll stop and then count that Z and then count over. An absolute encoder and the serial encoders have multiple lines on the discs, which are used for commutation, and also on the serial encoder it's used for feedback, to tell where the encoder talks, has microprocessors built onto the encoder itself, and it'll talk from the encoder to the drive.